3. Let's do this. We have a map of Europe on a coordinate diagram. Let's write down where S is. S is minus 2, 3. R is 1, 1. And T, where is T? Oh, there it is there. T is 4 minus 1. Use coordinate geometry method to show that airport R is exactly halfway between S and T. So we're going to use the midpoint formula to do that. So we call this x1, y1, and call this, oh sorry, not R, we're going to call S x1 and y1. x1, y1, and then T is x2, y2. So it's going to be minus 2 plus 4 divided by 2. And the other one's going to be 3 plus minus 1 divided by 2. And they're both going to be 2 over 2 and 2 over 2, which is the point 1, 1, which is in fact R. So R is the midpoint of S and T. Find S to T, the distance between airport S and airport T. So essentially we're finding how far this line is from S to T. Okay, so what we're going to do is going to use the distance formula. There they are there. So it's going to be square root of x2 take away x1 squared plus y2 take away y1 squared. Square root of x2, which is going to be 4, minus minus 2, because there's two minuses, which will make it plus 2 squared. And then it's going to be minus 1 and minus 3 squared. Put all that into the calculator. It should come out as root 52, but we'll do it the long way. 4.2 squared plus minus 1 minus 3 squared. 2 root 13, which is root 52. Yep, 2 root 13 or 7.2. Maybe we got 2 decimal places, 2, 1. Okay, that's C done. Now, D. If the scale on the map is 1 grid unit, it is 450 kilometers. An airplane flies from an average speed of 600 kilometers an hour and takes the most direct route. How long will it take to fly from S to T? Well, we said earlier that it's 7.21 units. So it's 7.21 multiplied by 450. So 7.21 multiplied by 450 is 3,244.5 kilometers, 3,444.5 km. And then speed equals distance over time. Which ends up to be 3,244.50 divided by time, which is, sorry, we're looking for time, so it's divided by speed, which is 600. So this, time equals distance over speed. That's my fault. Time equals distance over speed, which is that number divided by 600. So this will give me the answer in hours. So it's 5.4075 hours. Okay, now I'm going to multiply that by 60 to convert it into minutes. So 324 minutes. So 324 minutes to the nearest. Okay, that's D done. Question 4, so we've done question 3. Now we're going to do question 4. Shows that the total internal surface area of the tank is 28H plus 45. Alright, so there's the deal is here is that it only has 5 sides because the top is open, so it only has a base rectangle as well. Sorry, just gonna finish off around this first, okay? Whoop. There to there, and then there to there. Okay, a bit better now. Okay, so let's do the two side ones are h multiplied by 5. So you have a 5h on the left plus a 5h on the right. Okay, and they're the two side ones. Now we're going to do the front and the back, which will be the green rectangles. So this green rectangle here is the same as this green rectangle at the front, and that's going to be 9 across h up, so it's going to be two 9h's. Okay, and then the bottom rectangle is just going to be 45. So there's only one base triangle, and it's 45 plus 45. Now, how you'd show that is you'd show it as a 9 by 5. Then you might show your h by 5. And then I suppose you can show your 9 by h as well. So you can just have a quick diagram of what you're doing there, add them all together, and you get 28h plus 45 as predicted. Okay. Now, if the total internal surface area is this much, find the value of h. Well, we now know that 28h plus 45 is 143. So 28h equals 143, take away 45, which is 143, take away 45, 98. And then 98 divided by 28 should be 2.5, I think, or 3.5, 3.5. H equals 3.5 meters. Now we're looking for the volume of the tank, which is length by width by height. Length is 9, width is 5, and height is 3.5. So it's going to be 9 by 5 by 3.5. Which is going to be 157.5 meters cubed. Okay. Parts, yeah, 157.5 meters cubed. Water flows into the tank through a cylindrical pipe with internal radius 10 at a rate of 30 centimeters per second. Now remember, that's all in centimeters, so I'm going to change this to meters. 0.1 meters and then 0.3 meters. So essentially every second this much water is getting pumped in every second. It's like a cylinder of water gets pumped through every second. The height of the cylinder is 0.3, the radius of the cylinder is 0.1. Therefore the volume of the cylinder is pi r squared h, which is going to be pi times radius squared, which is 0.1 squared, times the height, which is 0.3. So shift pi times 0.1 squared times 0.3, which is this number here. Okay, so we'll take it as 9.425 by 10 to the minus 3 meters cubed is the volume of water pumped in per second. Now, what we're going to do is we're going to divide the total volume by this volume here. So if you imagine I had 200 meter cubed pill, and I was pumping the pill at 5 meters cubed per second. You divide 200 divided by 5 would say that you got it filled in 40 seconds. That's essentially what I'm doing here, except the numbers are a bit more awkward. Okay, so what I'm going to do is I'm going to divide 157.5 divided by 9.425 x 10 to the minus 3, and this will give me the answer in seconds, we're hoping. So 157.5 divided by 9.425 multiply, better use brackets here. Actually, I'll use a fraction maybe. There you go. By 10 to the minus 3, x 10 to the power minus 3. And it takes 16,711 seconds, or 700 and, yeah, let's do 711 seconds. Now divide that by 60 to turn it into minutes, and you get 278.51 minutes, which is 279 minutes, which is just over 4 hours, 4 hours, 39 minutes, okay? So, what have we done so far? We've done question 3 and question 4. Question 3 and question 4. The diagram in the circle is inscribed in a circle. AB is 48 and BC is 75. So we have 48 and 75. The diameter of the circle, AC is the diameter of a circle, and therefore ABC is a right angle. State a corollary or theorem on your course that confirms the above statement. Okay. Remember, a corollary is anything that forms, is any theorem that, state a corollary or theorem on your course that confirms it, okay? So what we could do is, we could say the angle at the center of the circle, this angle here, standing on a given arc, is currently standing on AC, is twice the angle on any point of the circle standing on the same arc. So this angle also standing on AC, which means the angle A here will be twice the angle of B. Okay, so you can state that. Or, so you can state this one here. Or you can say each angle in a semicircle is a right angle. Or, if the angle standing on the chord AC at some point of the circle is a right angle, then AC is the diameter. So any of those theories will do you nicely, okay? Next one. Find the smallest angle in the triangle correct to the nearest degree. Alright, so this is a trigonometry question. So not something you have to be too worried about at the moment. So I've done 3, 4, and this is question 6. So what we learned earlier is that AB is 48 and BC is 75. So that's 48. This one's 75. This is 90 degrees. This angle here will be the smallest one in the triangle. Okay, so what we can say is that tan x equals 48 over 75, because 48 will be the opposite and 75 will be the adjacent. So tan x, so that's the opposite, and you're the adjacent. Tan x equals 48 over 75. Tan inverse that to find the angle. Shift tan inverse 48 over 75, which is 32.61 degrees, which would be 33 degrees to the nearest part. Okay, and x equals tan inverse 48 over 75. In the diagram above, construct a line perpendicular to AC that passes through B. Construct all lines clearly. Construct a perpendicular line to AC that passes through the point B. Okay. Perpendicular to AC passes through B. Okay. So, I suppose what you could do first of all is you could do a perpendicular bisector to begin, and then draw a parallel line to that bisector. Will probably be your best bet. I'm just going to drag this down now because we just need to do the construction. I have a slightly better idea. Okay, so here's the idea I'm going to run with. I'm going to get C to A, I'm going to extend it a bit further out. Okay, then I'm going to get my line B. Okay, and what I'm going to do with B is that I'm going to make 2 lines away from B. So I'm going to do 2 marks away from B. So here's my first mark here. Okay. Oop. And then my second mark will be over here. Now what we can say is that these 2 points are equidistant from B. Okay. Now what we can do next is that if I do the perpendicular bisector of the middle of these 2 parts, so if this is a D and this point is E, if I do a perpendicular bisector, it'll go through the middle of D and E, which should be directly underneath B. all going well. Okay, so here's my first arc. Then I'm gonna keep it going downwards. Here's my second arc, just under D. I'm turn it around. Then I'm going to do an arc from E, which should be here. Then I'm going to do another arc. Ooh, I didn't make that first one long enough. It's annoying. Back we go to D. There we go. Now see those 2 points where they intersect each other? If I draw a line, it goes through B, and it also bisects. It doesn't bisect AC, but it's perpendicular to AC and goes through B. Okay. All right, that's that one done. So that's 3, 4, 6. Okay, that's done. 3, 4, 6. Now we're on to 7. Which line has the greatest slope? Well, we're going to use y equals mx plus c. The greatest slope would be the largest positive number. So this one has a slope of 2, has a slope of 1, has a slope of 4, has a slope of 3, has a slope of 2. Q is going to be get y on its own. So we're going to have a 3y equals minus x plus 1. Divide both sides by 3, y equals minus 1/3 x plus 1 over 3, and this is a slope of 1/3. So who is the greatest slope? The greatest slope would be 4, which is O. Which one has a negative slope? I think we figured out that line Q has a slope of minus 1/3. Which ones are perpendicular to each other? Now to be perpendicular, you have to be, if I was to ask you what's perpendicular to a slope of 5, it'll be minus 1/5. If I ask you what was perpendicular to a slope of minus 2/5, turn it upside down and you get 5 over 2, change a negative to a positive. These are perpendicular slopes. So it'll actually be 3 and minus 1/3. So it'll be M and Q are perpendicular to each other. Which lines cross at the same point? Well, we're looking for the C values to be the same. So N and O have the same C value. So I'd say N and O. Because remember, Y equals mx plus c. And the value at the end tells you where it crosses the y-axis. So these two here, because they have a 1 at the end, and it's y on its own the other side, they both cross at 0, 1. This one here would cross at 0, 5. Okay, so you can see most of them are different, bar N and O. A translation can be used to map line something onto line something. Now, translations. Okay, and next one is a translation, right? Now, translation, if you have an XY axis, okay, and the translation could be like a picture of, like, let's say a person, okay, stick person. A translation moves the same parts and it looks identical. Translation doesn't flip them upside down or anything like that. Everything stays the same. So if this is actually a true translation, wait, what would happen is you end up moving it to another part in the graph. So it starts here and you move it and it's the same shape. So essentially there's no changing of angles. So the only thing you can translate would be 2 parallel lines. Parallel lines are the only things that you can really translate. So which ones are parallel to each other is what we should be looking for next. Y equals 2x and y equals 2x minus 3. They're parallel. So let's use L and P. You could also say P could be mapped onto L. Which one passes through the origin? Well, this is one that has no C value. If you have no C value, it means you go through the origin. Okay, so line L will go through the point 0, minus 3. That's no good. Line M would go through the point 0, 5. That's no good. These two go through 0, 1. No good, no good. But this one here in the corner, line P, has no c value, it's essentially y equals mx plus c, but y equals mx plus 0. The c value is 0, so it must be line P. Okay, next one. A line K passes through the point 0, 2 and is perpendicular to the line L. Which one's line L? Okay, line L has a slope of 2. So if line L has a slope of 2, the perpendicular slope will be minus a half. Okay, so let's get the equation of the line here. So what we're going to get is y, we're going to get x1 and y1. So y minus 2 equals m, which is minus a half into x minus 0. Bring the 2 up, so it's going to be division of 2 on the right is multiplication of 2 on the left. Multiplying the minus 1, you get minus 1x. Bring the minus 1 over the other side, and we get x plus 2y minus 4 equals 0. Okay, so that is, what do we have done? We have 3, 4, 6, and 7 done so far. Oh, we got another one to do. Use algebra to find the point of intersection between K and L. So L is 2x minus 3. K is the answer we just got a second ago, which is x plus 2y minus 4. So we can use simultaneous equations to figure out where these two perpendicular lines intersect each other at 90 degrees. So we're going to bring the 2x to the left, so we're going to get minus 2x plus y equals minus 3. We're going to bring that minus 4 to the right, so we're going to get x plus 2y equals 4. Going to multiply the bottom equation by 2, and what we're going to get is the top equation stays the same, but the bottom equation is 2x plus 4y equals 8, I believe. Yep. Then we're going to get 5y equals 8 minus 3, which is 5, and y equals 1. Now if y equals 1, we can either sub it into a or b to figure out what the x value is. So I'm going to choose b. X plus 2 times 1 equals 4. X plus 2 equals 4. X must equal 4 take away 2, which is 2. So this is the point 2, 1. So we've done 3, 4, 6, 7. Question 10 is done on one of my other videos. You're to do this now, guys, and I will put up that proof on question 10 or on my other video. Okay, now question 11. Find the angle DEB. D to E, DEB. Alright, it's going to be an interesting one. So AB is parallel to DE, that's good to know. So this means angle CDE is also 33. So this one here is also 33. Okay. This angle here, ECD, is going to be 180 take away 135, which is, I'm hoping, 45 degrees. Okay, so that's 45. Okay, so this means that angle DEB must be 180 take away 45 take away 33 minus 45 minus 33, which is 102 degrees. Answer is 102 degrees. So 3, 4, 6, 7, 10, 11. Now, what's the next one we gotta do? Show that triangle ABC is similar to triangle CDE. Okay, so ABC, this one, and then CDE. Okay, so we already started off earlier with what's it? CAB, angle CAB equals angle CDE, because they are, what's that word, alternate. And our alternate is where you have the z's, where one of them is like that and the other one's like that. Basically, this angle here, you can see sort of a z there. This one's the same as that one there, okay? So that's that done. Now, what's the next one we're going to do? We're going to do ECD has to be the same as ACB because they're vertically opposite each other. So ACB equals ECD. Angle ACB equals angle ECD. Reason being is they're vertically opposite. So essentially this angle equals this angle, so vertically opposite. Okay, and then finally, third angle is the other side. So all three angles had to add up to 180. So ABC has to equal CED. So ABC equals angle CED. Reason being third angle. Okay, hence triangles are similar. Okay, happy days. What's next? CE equals 5, AC is 16, and BC equals CD. Okay, I'm going to need the diagram for this. So I'm going to have to copy and paste this diagram. Actually, give me a second. Just going to rub out my drawings so far. Okay, we'll go again. So I'm going to do this on my new page. Okay, so they're similar triangles, which is the main thing to remember. One of them's large and the other one's small. So I always tend to do large over small. Large one is ABC, small one is CDE. Okay, should be quite manageable. CE is 5, no bother. AC is 16, which is this one here. And BC equals CD, so BC is the same size as CD. Find BC. Alright, here's the hard one, right? So this is blue. We call this the blue angle, and it's the same as this one down here. Call this one the red angle, they're about the same as each other. And call this one the black angle because they're about the same as each other. Now, to 16, we're going to do large over small. The large side and its corresponding small side on the smaller triangle. Large side is 16, which is in between blue and red. And in between blue and red on the smaller triangle, we'll just call it length X. And length X is CD, and it's the same as length X BC. So 16 over X. No bother. Pick another side. Let's pick C to E, which is in between black and red, which is on the smaller side, so it will be 5. And then the larger triangle, that's B to C, which would be X. Now if we cross multiply this, we're going to get X squared, because X times X is X squared. 5 times 16 is 80. Going to square root 80. And what we get is 4 root 5, or 4.94. Or 4.9. Sorry, 8.9. I'm sorry, I'm getting that wrong. 8.9, excuse me. So we found it. Okay, answer is 8.9. Okay, next thing, question 12. So we've done 3, 4, 6, 7. 4, 6, 7, 10, 11, and now 12. Okay, axis of symmetry. Now remember, that's when you slice down the middle and both sides can fall on top of each other. So an axis of symmetry, there'd be 1 in a isosceles triangle. In a pentagon, that'll be 1, because you can fold the pentagon, the left side equals the right side. Basically, any angle in the pentagon can be split in half. So I think we're looking at 5 axes of symmetry here. So yeah, that's 5 axes of symmetry for the pentagon. A rectangle should be 2 because you can fold it lengthwise or you can fold it widthwise. So that'd be 2 for a rectangle. A parallelogram, I don't think has any. Can't fold it like that. Just doesn't fold over properly. You can't fold it that way either, so I'm going for 0 for a parallelogram. Parallelogram is 0. Now, circle has an infinite amount. Circle, once you go through the diameter, you can split it in half, and the diameter, you can go from any angle you want. There's too many, so you can say infinite or infinity. Infinite amount. Next question. We have hearts on a coordinate diagram. We have A, B, C, and D, and E. Okay, no bother. But write the table, which one's a translation and which one's the original one is what we need to find out. Where is the original one? Alright, so the thing about translations is that translations doesn't change the shape of the object. So when you go from a translation, you can map A onto B. So A to B is definitely a translation. Now, D is mirror image in the x-axis, okay? So D will be axial symmetry in the x-axis. So we say D is axial symmetry because we can see it's reflected in the x-axis, okay? The next one is central symmetry in OO. So here's a little trick. Join this point of the heart to this point here. Join the far, let's say join this part of the heart, which is the split to this part here. Okay, and you can see that all the points are starting to go through 0, 0. You can see that the heart is being moved through this central point here. All its parts are being moved through the central point and reflected out the other side. So that's going to be C. Now rotation about OO. Now rotation's an interesting one. Okay, so rotation about OO. Okay, so what I'm going to do here is I'm just going to do a heart here, like so. Okay, then I'm going to do a circle. Okay, and the circle is of radius. Yep, that'll do me nicely. Look at this. So I'm going to join the two of these together. I'm hoping. There we go. Now look what happens when I rotate it. Oop, I don't want to do that. Let's look what happens when I rotate it around. And see the way it should go up there exactly. Let's try this one more time. Okay, I'm just going to redo the center of the circle. See if we can get it exact. Okay. And once again, if I manage to, I think it knocks off its axis slightly when I do this. So I'm rotating this system so that the heart is rotating around 0, 0. And see the way it almost sinks in exactly with A. That's what it is. It's rotating around it. So that must be A. Okay, that's the best I can do with that, I'm afraid. I thought it would work out better. So A is rotation about 0, 0. Okay, and we're done.